So, hello, my name is Viktorija and I've been working for Wix right now for over a year, and half of it I've spent working with Detox mobile automation library. Today I will be talking about my experiences, how it works, and hopefully let you know some new stuff that you're probably gonna use or not use in the past, in the future. So, to start from the top, mobile apps are becoming increasingly popular. More and more daily activities that used to be done on computers or even in more primitive ways are now being done on our smartphones. And being so reliant on mobile apps mean that they must be very reliable. And for that, mobile applications need to be tested, and this is where QAs come in picture, doing manual and automation testing. Right now, the most popular automation framework for mobile is Appium, but for Wix and our React Native app, it wasn't the right instrument to avoid manual mobile app testing. That's why our developers thought of creating their own tool and called it Detox. So, in this stock agenda, you can see a short intro on React Native and some background on automation testing, just to give you the background about what I'm going to talk next, which is Detox. I'm going to do a quick Detox overview and some important technical details, and it's going to be followed by a live demo. If you have any questions during presentation, there's going to be some time for Q&A at the end, so please wait until then. So, React Native. First of all, for any of you who doesn't know, React is a framework created by Facebook. It came way before React Native. It's declarative, efficient, and flexible JavaScript library for building user interfaces. React is handling just the UI part. All the business logic, state management should come from pure JavaScript. React Native is also a framework created by Facebook. It is based mainly on JavaScript and is very similar to React. It compiles into application both for Android and iOS. There is a popular saying in developer community about React Native. Learn once, use everywhere. It's by now almost a slogan for React Native. So why did Wix choose React Native? First of all, we are mostly JavaScript developers company. There is around 500 or even more front-end developers right now. Also, Wix knows and had great experience with React by creating web apps. Also because of its velocity that you can develop application for both platforms at a time, and also there's a huge interest in community because this framework is being developed by a huge company, which is Facebook. So some terminology to give you more background about Wix app that you need to understand. So native is something that's being developed for a specific platform. It's being coded, use different technologies and different programming languages for both Android and iOS. JavaScript is shared code between platforms in React Native terminology, wise, and it runs single task at a time, and it holds all the business logic. Components are UI elements provided by React Native or built on demand, such as view, text or button. And bridge is used by React Native to pass information between the native and JavaScript side, and vice versa. Messages over the bridge are asynchronous. So right now you can see a small diagram how the bridge works like. First of all, user makes a click on a screen, or as we call it, a tap, and this information of the action goes into the native side and is being handled by native button handler, and then from the native side instructions go to JavaScript side where handler logic is being performed. After that, handler response is being formed and some UI rendering instructions are being formed and then sent back over the bridge to native side where native views are built, and then the user can see the outcome of his primary action. Of course, there are still some problems with React Native. Firstly, because it's a still new technology, and the documentation of it is still in the making. But because of a big community, you can find answers to your problems very fast. Also, there's no platform parity because there's always going to be difference between Android and iOS. And one of examples is that there's no solid navigation solution. For example, an iOS native navigation solution is swiping your screen, and for Android you mostly have different buttons. Also, it's hard to test native and JavaScript altogether. The bridge that we use is costing a lot of time to do information transferring from native to JavaScript, so we need to think wisely what we want to send through it. And also, it's a complex environment to code with. And environment complexity is strongly influenced by the difference between native and React Native. So as you can see, you need to use different programming languages. Also, native has a static variables type and React Native has a dynamic type. Native is multi-threaded, and in React Native you need to code single-threaded, and also in native you need to code your UI manually. Therefore, in React Native you have Flexbox, which makes coding all the views much easier. If a company were to create an application only for one platform, for example iOS, it would be much more sense to use only native, as it's faster and easier to code. But we are supporting our users on both platforms, and right now our application is somewhere about 80% JavaScript and 20% native. So right now I'm going to talk about automation testing in very high level, just to provide some background about what's coming up next. So probably you have seen this similar kind of pyramid that I'm showing right now, and basically it portrays a mindset that there should be more automation for the lower levels of pyramid, as it is faster to create them and they are more isolated. I must agree that this pyramid can seem a bit too simplistic, but it does provide a good rule of thumb when you think about writing automation tests. So a bit more about unit tests. Because they are pure code oriented, they are easier to write and maintain, and it naturally improves code quality because developers are testing their code before releasing them to QAs or to the users. And because of that, it's easy to find non-complex bugs easily. But there's also disadvantage in that it's pure code oriented, because it doesn't really represent actual user flows and it doesn't reflect app quality. Mock T2E tests are closer to code and closer to product than the unit tests are, and they meant to be more stable compared to end-to-end production tests, and they are easier to maintain also compared to production E2E. But there's also cons that mock T2E are harder to set up and write, and it still gives you limited confidence because you don't work with a real server, so you cannot find any bugs if they're happening in the backend. So production E2E, they can give you a lot of confidence for releasing your app and help automate manual QA work. If you do less QA manually, you can do faster releases, and that's what we are aiming to do with our app, to do releases of new version every day and release bug fixes and new features to our users seamlessly. So we chose to do production E2E. They do mock real user experience. They are easier to set up compared to mock T2E, and they are easy to write because you can depend on the test suites you've already prepared for manual work, and they give you high confidence because you're portraying all the flows that user is doing. But there are disadvantages that they're mostly slow because you need to wait real time for server responses or for actions to be made. They're hard to maintain, and they are less cost effective because of that, and most of it is caused by the production E2E flakiness. So one of the most annoying aspects of E2E test is flakiness, just as I mentioned right now, because tests sometimes fail without anything even changing. Flakiness happens because tests are non-deterministic. Every time test is running, things take place in a slightly different order. Consider a scenario where the app is making multiple network requests at the same time. What is the execution order, you might ask? It depends on which request completes first. This is an external concern depending on network and how busy it is. The traditional method of dealing with flakiness is adding various sleep commands throughout the test in attempt to force a certain execution order. This is a bad practice riddled with various fragile magic values of sleeps that often change because sometimes tests happen faster and sometimes they happen slower. So to avoid sleeps was one of the main reasons and main things why detox was created. So what is detox? Detox is a gray box E2E testing and automation library for mobile apps. Wix tried using Appium for approximately 2 years in general and for about 8 months together with React Native. It was understood that unreasonable portion of time went dealing with test flakiness instead of creating real features or more tests. It was hard to do E2E testing as the flakiness of tests caused different results on different machines and frequent failures in CI. So that's the main reason why detox was created. And just to elaborate the definition of it, it's important to mention that detox is cross-platform. It works both on iOS and Android. It's also made for CI. You can run your tests on CI platforms like Travis without any grief. Detox is test runner independent by default, and we actually use Mocha, but you can use Jest or Ava if you're interested in that. And also detox is automatically synchronized. So what is black box and gray box in comparison? Black box goes over the view hierarchy, looks for an element, and if it's not found, sleeps and continues looping and searching until an arbitrary timeout that we choose exceeds. Unlike black box, gray box has access to the internal memory of the app and can monitor the execution process. So being able to read that memory gives it the ability to detect what's happening inside the process. If there are any pending network requests, when the main thread is idle, other main threads, if other threads are idle, if animations have ended, and so on. But there are also downsides. Because of the gray box, app goes through a different compilation and running process, and it needs extra code and extra time for it to execute. But for us, it was worth sacrificing the simplicity to get this huge value in return of avoiding sleeps. So how does a gray box thing happen? It's a very simple graph because it is that easy. The app is checking every few milliseconds and it's listening to the callbacks from the internal memory, whether the app is idle yet or not, and it's continues checking until the app becomes idle, and then it advances to the next test step. Also, when detox tests execute, you actually have two different parts running side by side. So the first part is mobile app itself, usually running on simulator, and your tests are usually built once before running them on simulator. The second part is test suite that is running on Node.js using a test runner like Mocha. The tests are normally written in JavaScript. This part is running outside the app and it communicates with the app on the device over the network using a WebSocket. Because tests are asynchronous in nature, the tests rely heavily on async await clauses. So right now I will talk about detox configuration. So device configuration is defined in package.json file, and there are 5 main parameters. 4 of them are used every time because one of them is optional. So binary path defines the path to your app that is due to be tested. Type describes the device type you are using, whether it's iOS or Android, if it's simulator or a real device. Then the name of a device, for example, for iOS it could be iPhone 7 or iPhone 8, whatever is available in a simulator client list. And there's also a build parameter where you specify the command that the build is run with. And here you can see an example. It's all very easily declared and easy to read. Also, you can define different configurations for server and test runners. So popular use case for server to define whether you're using a real or mock server. So it means we can not only create production E2E tests, but mock E2E as well. And you can define a test runner configuration. By default, it would be Mocha if not defined, or Jest or Ava, just as I mentioned before. Also, you can select a different server configuration for any device type that you have declared before. And after you specify all the parameters that you want, you just need to simply run detox test with your configuration attached and your tests are running. So I'm going to talk about detox object right now. It's the object that is globally available in every test file, and it has 4 main methods. So init for initializing, before each, after each, and cleanup. So detox initialize or init reads the configuration that's been defined in package.json file. It starts a server, it loads a detox expectation library, and starts a simulator. Detox before each is called at the start of every test. It can start recording or logging logs or taking videos, and even though it's not mandatory, you can also apply the usage that you need yourself in this statement. After each needs to be matched with before each, so if something is started, it ends, and it must return a failed or passed value. But of course, there are cases when you want to skip certain tests. So in that case, for such test case, before each is not being called. So therefore, after each shouldn't also be called for pending cases. And detox cleanup, it's a phase where all the tests have finished. This is the phase where detox server shuts down. So device object is also globally available in every test file. It enables control over attached device, and right now there are 18 different functions and counting, because if there is a need from a community, internal or external, these functions are added. So I have highlighted in purple the ones that I personally use the most. So it's launch app, terminate app, open app from URL, send user notification, and enable and disable synchronization. About these two, enable and disable synchronization, I'm gonna talk a bit more later on. So device launch app has 10 different parameters that you can set. Also, again, I have highlighted the ones that I use mostly. So restart app, whether app should start from a fresh installation or should be just restarted. Also, should it launch from URL? For example, when you get some kind of external browser page or invitation from which you have a hyperlink for your application to launch. And you also can set runtime permissions. That is very useful because for most of the times when you install your app fresh, and launch it for the first time, you get certain pop-up screens. For example, give permissions to send notifications, give permissions to your photo library. So you can set them with runtime permissions and don't mind about them. So this is an example how launch app method would look like. And if the device and detox object would be viewed as a foundation of automated tests for detox, these three guys, actions, matchers, expectations, would be the building bricks, and with them you define what actions you want your test to perform. So what are they for? Matchers are meant to find UI events on your screen. Actions are for emulating user behavior, and expectations are there to verify element behavior. So here you can see the available matchers is by ID, by text, by label, by type, by trace. And sometimes it's not enough because developers not always think about the code they're writing, and sometimes you have something matching multiple times on the screen. So for more uniqueness, you can add with ancestor, with descendant, or and to add the different matcher at the same level that's not a parent or child. So here you can see the example how it looks like while searching for a matcher in Xcode. So at the top you can see class name, which would be in detox notation by type, that's RCT view. Also you can see below the description, which would be by text or identifier at the bottom. And in this case the identifier has even a unique ID attached. So compared these three matchers, it would make the most sense to match that highlighted element right here by ID. But sometimes it's not that easy. So an example here, you can see this screen that has a lot of toggles, and through the view hierarchy I can see that identifier for that toggle is just toggle without anything specific added. So then I thought of going deeper into to search for ancestor for this element, and then I found out that the ancestor element is also not unique for this element, as every card element is called the same. So then you can go by descendant again and try matching by text. So how would it look like in code? You await for element by ID toggle with ancestor notification list item, which is not unique in this case, and then with descendant allowed notifications. So actions. Basically they cover three mostly used categories in mobile app: tapping, typing, and scrolling or swiping. So tapping is either tap, long press, multi-tap, or tap at point. It's fairly simple. Then typing, you can type text one by one. You can replace text, which works as a paste in a text field, and you can clear text, which is very useful if you want to start your typing fresh every time. Scroll and swipe, there's not really much to add to this one. And right now you can see expectations. So to be visible and to exist might seem very similar, but to exist is mostly used when you don't want to scroll the huge list of items or something like that. You just need to know if the item is in your view hierarchy. So to be visible means if you have a long list, you need to scroll to that item, and sometimes it might take even like 20 seconds or such. But if you use to exist, all the view hierarchy that's been read, you can verify it in less than a second. And also you can verify if element has a text or certain label, or has a specific ID or a value. So manual synchronization, just like I promised you before, right now I'm going to be talking about device.enable synchronization and device.disable synchronization methods. So synchronization, Earl Grey automatically waits for the app to be idle by tracking the main dispatch queue, main operation queue, network, animations, and several other signals that performs interactions only when the app is idle. So what if app does not become idle? Then you need to disable the synchronization. An example here, I hope you can see that this is a button that is constantly moving because it's animated to move up and down. So this means that app is eternally busy while it's in this screen. It does not reach an idle state. So in your test, before going into such screen, you need to disable synchronization and then go to a screen and it's automatically idle right now, and then you can perform tests on it. And naturally, after you're done working with this test, when you get back from the screen that could not reach idle state on its own, you need to re-enable synchronization once again so that you're still getting the feel that user is getting. And if you were to forget to reset the synchronization, it resets automatically with every new app instance. But sometimes when you disable synchronization, and you go into some screen, there's still some stuff that needs to load in that screen. For that, you use manual synchronization that's being done with wait for, and it must have a timeout because in other way it would not work at all. It would not wait for anything, and it must be used together with expectation. If you waited for something and the timeout has exceeded, you need to verify if that element was seen or not. So now I'll begin writing tests. So I'm gonna do a very simple case of logging in and logging out flow, and you can see I have prepared test IDs already for myself. So the first thing you want to do is launch app that's being done in before each. So we start a mock server, which actually is a real server, but it just was called by our developers that way. I start Petri overrides, which sets all the experiments that we have at Wix to be set as if the user is anonymous. So there are nothing specifically set for it, and the app is launched from a clear state, meaning that it was deleted before. And permissions for notifications are set to yes, so that I don't get a pop-up when I log in. So right now I will start with tapping the email button I can see here on the screen. So basically I wrote a matcher right here and then added a tap action to it, and that's it. So right now I will see what happens in the screen when I tap it myself, and I can see that email input field appears, so I need to work with it right now. I will just copy this and then I want to type text into it, so some random email. And after some kind of an email is being typed in, I need to tap next. Okay, so I need to tap next. It's very simple again. And right now I have 2 input fields for password, so I'm gonna add the same password in both of them. At this point, if you have any questions, you don't need to wait. because it might not be too clear what I'm doing. I don't know. I've never done this before. And after I add the email here, passwords, I need to tap sign up. And after tapping sign up, I can verify that I see the home screen. So I have also prepared a test ID for that. And right now I will be writing an expectation which starts with expect. And then again, the same answer for the element. And then I need to verify, I need to add what expectation I am going to perform. So in this case, let's just do to be visible. After verifying that the home screen is visible after logging in, I will do a logout. So I need to go to my account module, so tap the bottom tab of it. After tapping this, I see that there's no such logout button on my screen. So for this, I'm going to do a scroll method that scrolls to the bottom of the screen until it finds a logout button. And I'm going to use a wait for that. Okay, I forgot it. So I'm gonna use my app helper for that. Okay, so in this function I use the wait for, and I'm waiting for element logout list item, that's this element, to appear on the screen, and until it's visible I am doing a scroll for 200 pixels down while this element is still visible. The element RCT scroll view is a thing I have in the background of my screen right now, so it basically spans the whole view.
Sorry, but what about different devices? For example, in smaller or wider resolution, the pixel number would be different.
Yeah, so that's the thing, that I am scrolling until the element is being found. So I don't care where it is, because I'm just gonna keep scrolling and repeating the same action again. Okay, after I scroll to that element, I need to tap the login button again. Okay, account module. And right now, when I tap logout, I get a native element onto my screen. And for native elements, our developers cannot set specific test IDs or add many traits to it. So in this case, I need to try to verify it by text, but I see that the text is not unique in this case, so I need to find a different matcher. So for that, I fire up the Xcode, I attach Wix1app process, and I click this button to see the view hierarchy of the app. And native elements are usually somewhere in the back. And I can see the logout button here. I see here that there's this class name UI alert controller action view. and I'll just check if for this element that also has text logout, it's not the same class name being used anywhere. And I cannot see of this element having such ancestors, so I'm going to use UI alert controller action view as ancestor for logout matcher. So await element. And right now I'm attaching ancestor by type. Can you check if the microphone you took is turned off? Because I think it's not. And right now that I found it, hopefully, I'm gonna tap on it just the same again. And after logging out, I will need to verify if the primary login screen is visible again. So I'll just add an expectation for that. Okay, so let's hope I did everything right. Okay, so I'll just check if the keyboard is turned off, because if the hardware keyboard is still on and there won't be any typing on the screen.
This would be middle part of pyramid, yes? This test?
No, because as I mentioned, this is actually a real server. It was just called a mock server because some small part of it is tweaked, for example, as the pet rovers. But everything that happens right now, if I would do any changes to user profile or such, if I would connect to the same account on my mobile device, I would see that the changes were saved. And you can see that the test was passing. And that's it of my presentation. I have another demo prepared if you're interested. This is a bit longer flow. Okay, I'll just show it. So in this demo, user logs into the app, and because it's a new user, it's also doing the type in password and verify password flow again. And after it logs in, it verifies that the empty state screen is visible, and right now it tapped join with invite code button, and the invite code is being typed in, place is joined. And after that, you verify that the site is visible in the home view. And now it's being hidden from home. It verifies that it was hidden and the empty state is visible again. And then it unhides it. So that's it of my talk. So thank you very much for listening and being with me. You can find everything in GitHub and apply to your project.